Hello, and welcome to the Data Action Lab podcast. Today, we will be talking about data visualization, which is a very hot topic right now. And in particular, we'll be talking about a data visualization that happens to be a favorite of both of the two other Data Action Lab folks that I have with me here today. The first being Patrick Boily, and the second being Stephen Davies, who are both super into data visualization. So I'm looking forward to hearing your opinions on the topic in general and also on the data visualization that you've chosen to discuss.
Thanks for having us, Jen.
Pleasure.
Okay, are you ready? Are you ready?
We are ready.
Full speed ahead.
You think you're ready? We'll find out. Now, the first question I have for you is, in your opinion, is data visualization more of an art or a science? Steve, your thoughts first.
There is science behind it, absolutely. There's a grammar behind creating graphics. There are rules that we can follow, methodologies that helps us to create good data visualizations. But saying that, there are some that actually are amazing. You know what I mean? And the people that create them, there's a little bit of art and magic to it. So I'd say, 70-80% can be taught. There is some methodology there, but I think there's a little bit of magic in there as well.
There's always room for that extra piece. Yeah. Now,
exactly. We can do that, and we can learn it all. But some people are coming up with stuff that's amazing.
So what's your take on it, Pat?
Well, I think you could argue that art also has a bit of a methodology to it, and painting has a methodology to it, and there's like steps, and it's not always explicitly stated what the grammar of painting is or the grammar of sculpture is. But I suspect that if you were to take artists, people who consider themselves to be artists, we could presumably boil down a lot of what they're doing to a series of steps and methodologies and specific techniques. But then there's, again, that other percentage that probably escapes our ability to really sort of like surround a corner or dissect, in a sense. There's a lot more art into data visualization than I would have expected.
Okay. All right. So in a sense, what you're sort of saying, I think both of you, is that there is kind of, like, for those who are new to it and they're starting out and they're not sure where to go, there is sort of hope for them. It's not that they just have to wait for the data visualization magic to fall onto them. There's a process and you can get somewhere.
Absolutely. And just something to add as well is there is a great sense of satisfaction in doing art. And the thing about data visualization is it's not about just creating another graph. When you get it right, you also get the same feeling of satisfaction, which is why I think so many people are passionate about it. Because from a self-improvement and just a fun thing to do, it can be quite magical. It can be quite interesting from that perspective. So it's arty in that sense as well.
Cool. It's a nice blend, it sounds like.
Also, presumably, if you think of artists trying to sort of convey a message, that's what data visualization sort of does. It's the only real reason why we do it, when we think about it, is to help us digest a fuller situation through the help of data. And then we're digesting that data further into some form which is consumable, that is telling us something. So, at least from my perspective, that's a very artistic endeavor.
How has data visualization evolved from its early days to now, would you say? Pat, do you think that things have changed, or is it the tools that have changed? Is it the techniques? What do you think the story is there?
So the tools obviously have changed. I remember not that long ago as an undergrad student where basically the only thing you had at your disposal was the ruler and a set of coloring pencils. There's only so much you can do with that. If only in terms of processing the data so that you can eventually visualize it, we are in a completely different space. But the species hasn't evolved that much over the last 2,000 years, 5,000 years, 10,000 years in terms of making sense of our environment and spewing out insights out of what it is that we're inputting. So I don't know that the concept of data visualization has changed that much, but certainly in terms of the size of the data set we can render or process, and the interaction with the user and the consumer, things have changed, of course, dramatically over the last 25 years.
Steve, is that how you see it as well, or?
Yeah, I mean, there's some fundamentals that I love going back in history, and I like cooking. I like going back to old recipes. There's some stuff that was done hundreds of years ago, which we are still not even replicating today. We should be. There's a lot of principles that were founded. But the big changes are things like interactivity. The tools now allowing us to interact. So, the biggest change, I suppose, is being online, being able to interact with a lot of these visualizations, sort of enriches the experience. But fundamentally, some of the stuff that was done, a couple of hundred years ago, even more than that, beats the pants off, 60, 70% of the visualizations that are done today, which is one of the reasons why we're doing this video, to learn a little bit from history.
So in terms of sort of the biggest advances, I mean, it sounds like interactivity would be it's a big change. I'm going to throw this out to both of you. Would you say that that's been the biggest advance, or what has been like the biggest advance? And we'll say like the last 10 years or so.
I mean, we understand things a bit better. We understand color theory better. We understand how things fit together better. We go back to this grammar of graphics. So I think now we can reproduce things with a lot more consistency. And familiarity is a big thing when it comes to visualization. So an organization that creates visualizations over time needs to be consistent in doing that, because that really helps the end user. So that's not the visualization itself, but it's the replication and the consistency of applied knowledge to creating that visualization, I think makes a huge difference.
There's a societal aspect to this as well. 10 years ago, Stephen, would you say there was, I don't know, like 200 of us doing this in a fairly large area? Now it feels with the tools, a lot of people can do it, and if a lot of people can do it, you get a lot more voices that are involved with the summarizing and the extracting insights from data. More voices typically means better things when it comes to these things. You remove the gatekeeping aspect or element of the process. I think look, especially since it's easy to collect data, and it's easy to fall into the trap of thinking that data tells the full story. No, there's a human element, how you choose to tell the story, what you choose to report on. If it's always the same 200 people, we're losing something. Now, over the last 10 years, I feel that everybody and their neighbor has heard of data visualization. Jen, even you, who, by all accounts, this is not your bailiwick. I've seen you do visualizations as well. You bring your unique voice to the process, and I think that can only be positive.
Yeah. Well, I think, as you say, there's been a bit of a democratization, I would like to think, of some of the tools. I've certainly seen more tools available, like, quick web apps that you can just make quick visualizations in. And as you say, I mean, for me, data visualization, even though I recognize it's crucial in one of these processes, it's not my primary thing. But yeah, I like to think that it is available to everyone if they need it, for sure.
Presumably as well, with democratization, though, there comes a need for those of us who've been doing this for a while longer to sort of also pass on the knowledge to make sure that people are not, I'm going to say dangerously, but aren't doing harmful visualizations, right? Because if everybody and their neighbor can do data visualizations, well, they can be used for harmful purposes, but they could also be misused or misdone or mishandled, and that can actually create some challenges for the data visualization community down the road.
Yeah, that's an interesting topic. I'm gonna go off piste a little bit from my originally planned questions, because I think I would pursue that in terms of, right now there's a lot of discussion about sort of false news, and that implies an emphasis on the written word. But what do you two think about kind of that false news issue as it connects to data visualization, Pat? This is kind of what you're bringing up a little bit.
So, is it deliberate or not? The issue is that, can you easily create something that misleads a person that's looking at the visualization? And with the explosion of tools that's available, and some of these take a little bit of training to use, we do a lot of tools training ourselves, right? People can not deliberately aim to mislead, but by not understanding the tool and creating something that just looks great and looks cool, and then publishing it without forethought, that can be misleading in itself. The problem then becomes if somebody then does have malice of forethought with these tools and with the sophistication of the tools, they can end up being very, very, very misleading. We see this on social media. We unfortunately see it on some of the larger news networks. I mean, this does go on, and in terms of the media narrative, there's lots of examples over the last 2 or 3 years where we've seen the creation of data visualizations that have been less than honest.
I think we also see this at this, at the state level. Like, I'm thinking of a recent state of Georgia visualization about like the number of cases of COVID-19 spread out over a certain amount of time, and you can see where it's. I want to say obviously. I'm going to be charitable here and say that it's not obviously malice, but it certainly betrays a lack of understanding of the principles, I think, and that can cause a fair amount of problems down the road. I mean, for COVID-19, we know what the problems might be, so it's not always an academic exercise, right?
Yeah. I mean, the COVID-19 one, that's a great one. I think, in a way, I'm hoping that will promote some digital literacy, some data literacy on this topic.
It has introduced certain things, and one of the other things to think about with visualizations is some education is also needed. So, the obvious example that COVID has taught the populace at large is logarithmic axes as opposed to linear axes, right? And that's a hard sell, right? And not everybody's convinced, but there is now a broad understanding why there are two different approaches in terms of just plotting data out. So these events do help in that context, but it also shows that we need to be able to educate people, because if they're not educated, they will misinterpret. Right? If you don't understand an axis is a log axis, you'll just come up with a completely different interpretation of that chart, even if it was well intended.
Okay, so I'm going to switch tracks a little bit now and get just like a little bit more nitty gritty for my last general question. Do you think there are certain types of data that better lend themselves to visualization? Steve.
So I'm not going to comment on types of data because we can cut that in a million different ways. For me, all data can be visualized in some way, shape, or form. The data that is interconnected in some way, I'm not going to use the phrase correlated or whatever, but data that is interconnected gives you more options when you create your visualization. So if I'm looking at a data set and there's lots of data points and lots of references and lots of things that I can bring together, that I can link together, that gives me a lot of options when it comes to creating charts and dashboards. And when we start looking at some of our examples, we'll see that one in particular is very rich because of the different types of data that were brought together, right? And that really helps to create the visualization. Anything can be visualized, but for me, that's a fun challenge to work out what angles do you take, how do you chop the data, what do you link together, and what do you represent? So that personally for me is an interesting way of looking at it.
Right. So basically, you have a lot of dimensions and a lot of rich relationships. That gives you a lot to work with in terms of
absolutely.
What you can visualize.
Yeah, absolutely, very much.
Right. Pat?
Well, from the point of view of ease of work, obviously numerical data is better than categorical or text data, because you can just plug it into, say, base R, or even like a quick plot function in ggplot2, and you'll automatically get something, and you don't really have to think about it. So if it's if what you're interested in is easily setting it up so that you can start working and producing things, numerical data is typically better. But from the point of view, you get better charts, or you will have to dig deep at some point. You never just do what I've described. That cannot be the end of the story. Perhaps as a 0th pass, or even as a -1th pass, you might want to do this. But ultimately, to get something that is going to be useful, that's going to convey insights, that's going to help decision makers or the general public understand what's supposed to happen, you need to invest a fair amount of time into producing the visualization, in which case, well, you'll take the time to deal with the categorical data or the text data or any of these other things. If speed is one of the factors you use to determine what kind of data you should use, then yes, obviously numerical data, easier to work with. But I would suspect that in many instances, it's easier to get insights if you've categorized or binned the data to some extent, in which case, whether it's numerical or text or categorical, it's half a dozen of one and 6 of the other.
Okay. So it's like, if you get the numerical data, it's like, boom, we have all the techniques. It's fast. We have all the known sort of strategies. Let's just get it up there. With other types of data, you're going to have to work harder. Do you think that that's because there's fewer available insights in that data? I'm agnostic on this. I'm just asking you as a genuine question. Do you think there's fewer available insights in categorical data?
I don't think so, Jen. I think the hurdle, if you want to call it that, comes from the fact that, we all remember high school where we had to trace a straight line on an X and Y axis, and we might have learned how to trace the conic sections as well, and some of these things. It's just a habit. Like, we got into the habit of dealing with numerical data with, from an analytical perspective, but in the real world, a lot of the inputs that we sort of take in and process to come up with insights or conclusions or strategies, a lot of those are categorical as well. So I think a lot of the pushback, if you want, against these other ways to look at data is mostly we're not used to them. We don't have enough practice with them. It isn't that they're more difficult, not any more difficult than learning to drive on the left side of the road as opposed to the right side of the road. There's no evolutionary reason why we drive on the right, and so you can unlearn things pretty quickly as well.
And this is interesting because this kind of brings it back full loop, going back to the art question, right? I mean, in my head, very often when I'm talking with clients, we're talking broadly about qualitative and quantitative data. And, the data that is implied or gut felt as opposed to being very cleanly laid out in a database. And the nice thing about data visualization is that if we look at it not just from here's a piece of software, let's create some charts, but if we think about it from a more art perspective, there are lots and lots of examples of people representing actually quite fuzzy, qualitative data, for want of a better phrase, that is amazingly well communicated and is able to tell a story and inform the end user, even if it's not ones and zeros being replicated on a chart, right? So there's a little bit of a fuzziness in this sometimes, but if we broadly stand back and look at data visualization, we're able to encapsulate all of that as well.
Yes. I mean, one of the things I've seen with some clients as well is they want to know, well, what should I do in all cases? Give me a list of steps to follow always. And he's like, well, no, we can't do that. And we shouldn't do that, because then if you automate everything, there's no sort of like a process of consuming the visualization to derive the insights from it, right? And so from my perspective, it's almost beneficial that data doesn't always lend itself nicely to visualization, because it forces you to roll up your sleeves and to say, well, hang on, I have some agency here. I can make decisions that are going to drive the visualization process. I'm not just a victim of the type of data that I have. And so having said that, obviously there are suggested charts for specific types of data. Like if you have time series data, you probably want to come up with a line chart or something along those lines, right? And so if you have categorical data, perhaps a bar chart. So it's in many instances, our experience suggests a bunch of potential charts that would be better suited to specific types of data. But I'd rather people take the time to really sort of explore the situation so that they can come up with the right visualizations for the right time and place and data that they have.
And as an amazing segue, potentially into one of the things we're going to look at in more detail. The example here takes some very qualitative data, but the way it's visually representative is actually quite fuzzy and quite quantitative, because we are looking at broad ratios that we don't measure and we don't understand, but it still gets the story across, right? So that's a really good example of that.
Yeah, that's actually what I was thinking too, is I was like, oh, this does relate to the visualization you folks want to talk about, right? Like this question of like, how did they tackle this challenge that you're talking about? Yeah, I think this is a very topical, relevant discussion, particularly in the context of the next video that we'll be presenting. And that is a video looking very specifically at visualization that I want to say is maybe one of the favorites of both of you, and that is the March to Moscow visualization.